The Japanese hid a technology in their tank that no other country in the world possesses. Almost $10 million for one tank. This is not a typo and not a joke. This is exactly how much the Japanese Type 10 main battle tank costs, which is the second most expensive tank in the history of mankind. But why pay such insane money when you can buy a combat-proven American Abrams or a German Leopard for half the price? The answer lies in a secret technology that Japanese engineers developed for decades and which still no other country in the world has. However, to understand how Japan came to create this steel monster, we will have to go back almost 100 years into an era when Japanese tank crews accomplished something incredible, and then their own command destroyed everything they had achieved. The year 1937, China, the Battle of Rehe. Japanese troops invaded enemy territory and encountered a powerful defensive line of the Chinese army. Infantry attacks stalled, casualties grew, and then the command made a decision that changed the course of the battle. Small Japanese Type 89 tanks, vehicles weighing only 12 tons, received an order to break through the second line of enemy defense. The tank crews executed the mission brilliantly. The armored vehicles swept through the Chinese positions, sowing panic and chaos, while the infantry rushed into the resulting breach. This was a classic tank attack with a deep breakthrough. And the most astonishing thing was that the Japanese pulled off this maneuver several years before the Germans became famous for their lightning blitzkriegs in Europe. It would seem that Japan had found the key to victory. Tank units proved their effectiveness. Tank officers were developing a new doctrine. Engineers were working on more advanced vehicles. But then, a catastrophe occurred, and the blame lay on one man, General Hideki Tojo. This staunch supporter of infantry tactics came to power and began to methodically destroy everything related to the tank forces. Tojo believed that a real Japanese warrior should fight with a rifle and a bayonet, not hide behind armor. Tank units were disbanded, funding was cut, and officers who advocated for the development of armored forces were sent to secondary positions. The consequences of this decision turned out to be monstrous. When Japan faced American troops on the islands of the Pacific Ocean, its tanks looked simply pitiful against the background of American Shermans. Japanese vehicles were pierced right through. Their thin armor could not withstand even the fire of heavy machine guns, and their weak guns could not cause serious harm to the enemy. By 1944, at the peak of military production, Japan was able to produce only 925 armored vehicles. For comparison, the Soviet Union produced about 29,000 tanks and self-propelled guns in the same year, and by 1945, Japanese production collapsed to 256 units of armored vehicles per year. This was a complete disaster, and thousands of lives of Japanese soldiers had to pay for it. After the capitulation in 1945, Japan found itself in a unique position. Article 9 of the new constitution prohibited the country from having full-fledged armed forces, only self-defense forces to protect its own territory. No offensive operations, no military bases abroad, no ambitions of a great power. It seemed that Japanese tank building had died forever and would never revive. But the Cold War made its adjustments. The Soviet Union was rapidly increasing its military power in the Far East. Thousands of tanks stood in garrisons along the border, and American strategists seriously feared an invasion of the Japanese islands. Washington pressured Tokyo, and the Japanese had to urgently create their own armored forces. At first, these were American vehicles transferred under the Military Assistance Program, then licensed production, and then Japanese engineers began to develop their own projects. Type 61, Type 74. Each new tank became more advanced than the previous one, but they all remained in the shadow of their Western counterparts. The Japanese learned, gained experience, accumulated technology, and waited for their hour. This hour struck in 1990, when the Type 90 tank entered service. The first truly modern Japanese combat vehicle capable of fighting on equal terms with the best tanks in the world. 50 tons of armor and steel, a powerful 120mm gun, an advanced fire control system. The Type 90 was created specifically to counter the Soviet T-72 tanks, which could land on the northern island of Hokkaido. But this tank had a serious flaw that the Japanese military realized too late. 50 tons of live weight. This is exactly how much the latest Japanese Type 90 tank weighed, and this exact figure became its curse. When the engineers of the Mitsubishi Company designed this vehicle, they thought about only one thing: how to stop Soviet tank columns on the snow-covered plains of Hokkaido. The northern island, with its mountains, swamps, and vast open spaces, was ideally suited for heavy armored vehicles. Here, one could deploy a classic tank defense, use the terrain, and set up ambushes in mountain passes. But Japanese strategists made a critical mistake. They forgot about the rest of their country. The Japanese islands are pierced by a network of almost 18,000 bridges. Narrow mountain roads, ancient bridges over rivers, tunnels, and overpasses, all transport infrastructure was created for civilian needs, not for moving heavy military equipment. When the military tried to move Type 90 tanks from Hokkaido to other islands, they faced an unpleasant surprise. The 50-ton steel giant could safely drive across only 40% of Japanese bridges. The remaining 60% simply would not withstand its mass. Of course, a bridge will not collapse instantly if the permissible load is exceeded, but nobody was going to risk expensive equipment and the lives of crews in peacetime. And in wartime, a destroyed bridge would mean the loss of a critically important transport artery. This problem was felt particularly sharply on the southern islands of the Ryukyu archipelago. Chains of tiny patches of land stretching from Kyushu almost to Taiwan itself. Narrow roads, weak bridges, extremely complex terrain. Moving heavy tanks here was practically impossible, and these exact islands suddenly found themselves in the center of a geopolitical storm that overturned all of Tokyo's strategic calculations. The Soviet Union collapsed in '91, and the threat from the north weakened sharply. But the old adversary was replaced by a new, rapidly growing China. Beijing modernized its fleet, increased its marine infantry, and louder claimed rights to disputed territories in the South China and East China Seas. The Senkaku Islands, which the Chinese called Diaoyu Dao, turned into a constant source of tension between the two powers. Chinese ships regularly entered Japanese territorial waters, and military analysts in Tokyo seriously discussed the possibility of a landing operation on the southern islands. Japanese strategists realized a frightening truth. Their country is practically devoid of defensive depth. What does this mean in practice? In the event of an invasion, there is simply nowhere to retreat. Ukrainian troops could withdraw hundreds of kilometers deep into their territory, stretching enemy communications and exhausting the adversary. The Japanese are deprived of such a luxury. At any point of the archipelago, it is less than 160 kilometers to the ocean. The enemy lands on the shore, and you are already fighting with your back against the water. Every meter of territory becomes critically important. Every defensive position must be held to the last. In such conditions, a completely different tank was needed. Light, mobile, capable of being quickly deployed throughout the archipelago and taking up defensive positions before the enemy has time to establish a foothold on the shore. And in 2002, the Mitsubishi Heavy Industries concern received a secret contract to develop a fundamentally new combat vehicle. The project received the code designation MBTX, and its parameters seemed almost impossible to the engineers. The military demanded the impossible, to create a tank that would weigh significantly less than 50 tons, but at the same time would not yield in protection and firepower to the best Western models. The vehicle had to pass through the majority of Japanese bridges, be easily transported by standard transport, and instantly deploy on any section of the coast. At the same time, the tank had to carry a powerful gun capable of piercing the armor of the latest Chinese and Russian vehicles. Mitsubishi was not facing such challenges for the first time. This corporation, founded back in 1884, had turned into the 23rd largest defense contractor in the world by the beginning of the 21st century. It was at the Mitsubishi shipyards in Nagasaki that the warships of the Imperial Fleet were built. And that is precisely why the Americans chose this city as the target for the second atomic bomb in August 45. Now, the descendants of those engineers had to create a weapon that would protect Japan from new threats. Work on the MBTX project went on under conditions of the strictest secrecy. Engineers experimented with new materials, calculated layout options, and looked for ways to reduce weight without losing protection. They knew they were creating not just another tank, they were creating a vehicle that was supposed to revolutionize armored vehicles. And in 2006, the first prototype rolled out of the factory gates. 40 tons in the minimum configuration, Japanese engineers managed the impossible. The new tank weighed 10 tons less than its predecessor, and this changed absolutely everything. At this weight, the vehicle could safely drive across 84% of all Japanese bridges, whereas the 70-ton American Abrams could manage only 40%. But the real revolution was the concept of modular armor, which no tank in the world had used before. The designers of Mitsubishi proposed an ingenious solution: 3 weight configurations for one vehicle. In the minimum configuration, the tank weighs 40 tons and is intended for rapid deployment on roads and bridges with limited load capacity. The standard combat configuration adds additional protection modules and brings the weight to 44 tons. This is sufficient for most combat situations. And the maximum configuration with reinforced armor blocks all over the hull gives 48 tons, and even this is significantly lighter than most Western counterparts. This approach allowed commanders to adapt the equipment to a specific mission. Need to urgently move a tank company to a remote island along narrow mountain roads? We remove the additional modules and send the vehicles in the lightweight version. Getting ready to defend the coast against a landing with heavy armored vehicles. We hang the maximum protection and dig in at positions. No other tank in the world gave such flexibility of use. But reducing the weight was only half the task. The Japanese islands are mountains covered with forests, narrow valleys, terraced rice fields, and endless climbs with steep descents. A conventional tank with a rigid suspension turns in such conditions into a clumsy dinosaur, incapable of properly aiming on a slope or using natural cover. Mitsubishi engineers solved this problem with the help of an advanced hydropneumatic suspension, which turned the Type 10 into a real acrobat. The system allows the crew to instantly change the height of the hull and tilt the vehicle in any direction, raising or lowering individual road wheels. In practice, this looks almost fantastic. A 40-ton steel giant can literally bow, crouch to the ground, or raise its nose up. Video recordings of tests, in which the tank writes Japanese characters with the barrel of its gun, went all over the internet and forced military experts around the world to admit the Japanese created something unique. But behind these spectacular tricks hides a deadly serious combat potential. When a tank fires from a hill or from behind an embankment, the ability to tilt the hull allows for the maximum use of cover, exposing only the turret with the gun over the obstacle. The enemy sees a minimal target, while the Japanese tank crew retains a full field of fire. When shooting on a slope, the suspension automatically compensates for the tilt of the terrain, keeping the gun in a horizontal position and ensuring accurate aiming where a conventional tank would be forced to drive out into an open space. Tests of the new vehicle began in 2008 at the training grounds of the Self-Defense Forces. Tank crews practiced combat coordination. Mechanics studied the features of maintenance, and engineers collected data on the reliability of all systems. Special attention was paid to the electronic interior, which brought the Japanese tank to a completely different level compared to competitors. Each vehicle was packed with computers, sensors, and communication systems that turned a single tank into a node of a reconnaissance and strike network. The tests concluded at the end of 2009, and the results exceeded all expectations. The Ministry of Defense of Japan officially adopted the vehicle into service in 2010, assigning it the designation Type 10. By the spring of 2020, Japanese industry had produced from 76 to 106 units of the latest tanks, which gradually replaced the outdated Type 74 and complemented the heavier Type 90. But the main secrets of the Japanese tank were hidden not in its suspension and not even in its modular armor. The real technological breakthrough was the armament, which was created for this vehicle by the Japan Steel Works Company, a legendary manufacturer whose history goes back to the beginning of the 20th century. It was this factory that manufactured the giant gun barrels for the battleship Yamato, the largest warship in history. And it was here that the gun was developed that placed the Type 10 on a par with the best tanks on the planet. The 120mm smoothbore gun Type 10 looks shorter than similar guns on the Abrams or Leopard. 44 calibers of barrel length against 55 calibers of the German Rheinmetall gun, it would seem that a shorter barrel means a lower initial projectile velocity and worse armor penetration. But Japanese metallurgists prepared a surprise that astonished the whole world. 640 megapascals of pressure in the gun chamber. Such a figure will not be sustained by any tank barrel in the world except the Japanese one. For comparison, this pressure exceeds the figures of American and German guns. And the secret lies in a unique technology that Japan Steel Works engineers developed for decades. This company, founded in 1907, became famous for the production of ultra-pure steel using a special technology that still remains a commercial secret. Every year, the factory releases a limited batch of traditional Japanese swords. And the masters claim that modern Japan Steel Works steel is not inferior to the legendary blades of ancient armorers. It was this metallurgical magic that allowed the creation of a gun working at the limit of physical capabilities. Special alloys withstand the monstrous pressure of powder gases, which would rupture the barrels of an American Abrams or a German Leopard from the inside. And since the pressure can be increased, it means the projectile can be accelerated to a speed unattainable for other tanks. The result amazed even the developers themselves. The initial velocity of an armor-piercing projectile from the Japanese gun reaches 1,780 meters per second, which exceeds the performance of the praised Abrams. But the Japanese went even further and created a special ammunition that fits only their gun. An armor-piercing, fin-stabilized, discarding sabot projectile, which received the same designation Type 10, weighs 7.8 kilograms and carries an increased powder charge. The pressure in the chamber during its firing is so high that this ammunition is physically impossible to use in other NATO guns of 120mm caliber. Their barrels will simply burst. The Japanese Ministry of Defense keeps the exact characteristics of the armor penetration of this projectile in the strictest secret. But Western experts estimate its capabilities as comparable to the best American and German ammunition, and possibly even exceeding them. All this firepower is complemented by an autoloader, conceptually similar to the system of the French Leclerc tank. 14 projectiles are located in the autoloader mechanism, ready for immediate use. Another 2 projectiles are stored behind the gunner's back, and 6 additional munitions are placed in a compartment next to the driver in the front part of the hull. The total ammunition capacity is 36 rounds, less than the 45 projectiles on the Russian T-72. But the Japanese military deliberately accepted this limitation. The logic is simple. The tank was created exclusively for the defense of its native islands. The vehicles will always fight not far from supply bases and will be able to quickly replenish ammunition. Unlike an advancing army which has to drag long supply trains behind it, Japanese tank crews will defend their land and can always count on nearby ammunition depots. On the other hand, the rate of fire of the system is impressive. One shot every 3.5 seconds, which is faster than its predecessor Type 90. In addition to the main caliber, the tank turret is adorned with a coaxial 7.62mm machine gun and a heavy 50 caliber machine gun on the commander's cupola. When all three weapon systems open fire simultaneously, the sight resembles scenes from sci-fi movies. Streams of tracers rush toward the target from all barrels of the vehicle. However, even the most powerful gun is useless without reliable protection for the crew. And here the Japanese applied their main trump card, the mysterious nanocrystalline steel, which became the calling card of the Type 10 tank. What kind of material is this, which is advertised by Japan steelworks specialists? The exact composition and production technology are classified, but open sources point to steel of a special structure that is 3 times harder than conventional tank armor. Under the layers of composite protection hides a base made of this unique material, providing more protection for each kilogram of weight. Critics point to the visually weak side armor of the tank, but experts respond, what is shown at parades and exhibitions can differ greatly from the real combat configuration. The Japanese military does not reveal all secrets, and demonstration samples may well carry lightweight modules instead of full-fledged protection. In addition, the Type 10 was created for a specific tactic. The vehicle will stand in a trench or behind a concrete cover, exposing only the most powerful frontal projection toward the enemy. Side armor in such a situation simply does not play a decisive role. The Ministry of Defense conducted tests during which armor-piercing projectiles were fired at the tank from a distance of 250 meters, practically point-blank by tank standards. The results are classified, but the official statement says that the composite armor demonstrated the required characteristics, and in terms of frontal projection protection, the new tank surpassed the heavier Type 90. Laser warning sensors are installed on all 4 corners of the turret, instantly warning the crew that the enemy has taken the vehicle in their sights. This system gives precious seconds to get out of the line of fire or deploy a smoke screen. 1,200 horsepower under the armored hood. An 8-cylinder diesel engine accelerates the 40-ton machine to 70 kilometers per hour on the highway. But what makes this tank truly unique is not the speed forward, but the speed backward. Thanks to a continuously variable transmission, the Type 10 is capable of moving in reverse at the same speed as forward, 70 kilometers per hour. No other tank in the world has dreamed of this, and this feature turns the Japanese vehicle into an ideal tool for the tactic that tank crews call shoot and scoot. Imagine the battle scene. A Japanese tank pops out from behind cover. Its fire control system instantly locks onto the target. The gun belches a deadly projectile, and the vehicle rolls back at full speed, hiding behind a terrain fold before the enemy has time to aim their weapon in response. The exposure time is reduced to a minimum. The chances of getting hit drop significantly. The faster the tank goes into cover, the more effectively this tactic works. And the Type 10 has no equals in this respect. The power-to-weight ratio is 27 horsepower per ton, an excellent indicator that provides the vehicle with rapid acceleration dynamics and excellent maneuverability. For comparison, the heavy Abrams has this indicator significantly lower due to its huge weight of 70 tons. Japanese engineers bet on mobility instead of thick armor, and in the limited space of their native islands, this philosophy works flawlessly. But the real revolution is hidden not in mechanics, but in electronics. Even at the design stage, the Ministry of Defense insisted on the implementation of advanced systems of command, control, communications, computers, and intelligence, what in military jargon is called the abbreviation C4I. When the vehicle was officially adopted into service in 2012, it already carried advanced electronics on board that were ahead of their time. The onboard computer of each tank is capable of simultaneously detecting and tracking up to 8 targets in its sector of view. Information about the coordinates, type, and status of the enemy is automatically transmitted to the unit commander and all vehicles of the platoon. The loaded database allows the system to independently identify enemy equipment by its silhouette. A T-90 or a Chinese Type 99 are recognized instantly, and the crew receives data on the most vulnerable zones of the enemy armor. But the most elegant function of this system is the automatic distribution of targets between the vehicles of the unit. The computer of the commander's tank analyzes the situation and assigns priority targets to each crew in such a way that 2 tanks do not accidentally open fire on the same enemy vehicle. This coordination occurs in real time, without voice radio communication, which is critically important in the chaos of modern combat. Data on positions, the condition of vehicles, and detected targets can be transmitted up the chain of command, right up to the corps level, creating a unified picture of the battlefield for all levels of management. Interaction with infantry and artillery reaches a new level. Tank crews can transmit target coordinates to artillery batteries, receive data from infantry scouts, and coordinate actions with fire support helicopters. For a country that historically had limited experience in tank operations, the introduction of such an advanced network architecture means a giant leap in tactical literacy. However, even the best electronics and the most powerful gun will not save a tank from modern threats if it cannot protect itself from missiles and drones. In 2022, video recordings of tests of an active protection system on the Type 10 chassis appeared. Specialists noticed potential mounting points for a complex capable of intercepting incoming grenades and anti-tank missiles. Perhaps the Japanese military expects that as these technologies mature, they will be able to provide the vehicle with all-around protection against projectiles and missiles without increasing mass through additional armor. The question of price remains debatable. Almost $10 million per unit is colossal money. But economists point out that every dollar spent on domestic production remains inside the country. Jobs at the factories of Mitsubishi and Japan Steel Works, taxes to the state treasury, the development of critical technologies, independence from foreign suppliers. All this is acquired along with the tank. In the event of war, Japan will not face a situation where allies refuse to supply spare parts or ammunition. Every component of the vehicle is produced on native soil, and this is a priceless advantage. From the shameful defeats of the Second World War to the creation of one of the most technologically advanced tanks on the planet, Japan has traveled an incredible path. A country that was forbidden to have an offensive army built a defensive machine capable of stopping any aggressor on its shores. Nanocrystalline steel, an ultra-powerful gun, a network architecture of combat. All these technologies make the Type 10 a worthy opponent for any adversary.